Okay. Shout out to all the people who aren't here, like Will Kozelski and who else? Emily, Joey Simon. Is that it? All right. We hope wherever you are, we hope state swimming is going well. And where's it? Is Emily at state swim? Washington D.C. Say hi to Obama for us. We're buds. All right. You saw it on Facebook? All right, here we go. I did a master's degree a couple years ago, and the action research project, the big thing I did at the end was the study of graphic organizers and their impact on the learning of higher level secondary math students. So what that means is I was wondering, do graphic organizers, like this little box that we make, does that help students learn better? And it does. If you want to make these boxes, go ahead. If you don't, that's fine. It's up to you. But I encourage you, I will continue to use these throughout pre-calculus as well as calculus, and the boxes work out. So let's read the problem. A farmer is making a pen on 480 yards of fence. He will be dividing the pen into 3 sections. All are equal size. What dimension should he make the pen to maximize the area? That is our objective. Maximize the area. Now, I want to be clear here. If we want to maximize the area, you could try to guess what kind of shape you should make, and chances are you would not be correct. For example, a square is often the thought. It's incorrect. So, again, I just want to pose this to you. Your chances of getting this question right without learning what we're doing today are very, very small, unless you would take a lot of guess and checks. Okay, so let me teach you how to do it. You'll see the secret. Rectangular pen, divided into 3 sections, all equal in size. So you can see the first box says model. I'm going to model the type of problem. Okay, I'm going to draw an example. Then I'm going to express the formulas or relationships that we are going to use. You tell me, if I'm trying to maximize the area, what formula should I write down? Sure, area is equal to L times W, length times width. We'll use that. So, I'll look back at my drawing. What should be W? Right there. But I have fencing down the middle because I'm dividing this up into 3 sections. So if I want to write an equation for area, I don't want 2 variables, I want 1. And if I want to go from 2 variables to 1, I need 2 equations instead of 1. So I need another equation. Can you use information from this problem to come up with another equation? 4W plus 2L is equal to what? 480. Now I can solve for a variable. I'm going to solve for L. 2L is equal to 480 minus 4W. So L is equal to 240 minus 2W. What can you now do? Excellent, Jack. That was definitely a question that Will would never get correct. But Jack, you answered it perfectly. Area in terms of what is the variable we're now using? W is the variable we're now using. Oh, I drew the arrow to the wrong spot. I'm sorry, guys. There we go. Area in terms of W, I have 240 minus 2W times W. Or area in terms of W is equal to 240W minus 2W squared. That is the equation or the function that I'm using to represent my real-world problem. Notice that the area can be calculated by not knowing what the length is, but simply given the width. We want to maximize the area. Here's where the aha moment needs to come in. What shape does that make? A parabola. Right side up or upside down? So will it have a max or a min? It has a max. So if we are trying to figure out how to maximize the area and we're looking at the shape that the function makes, which spot of the parabola are we trying to find? Describe to me, what is that point? The vertex. So we're trying to find the vertex, the location of the maximum. How do you find the vertex? Negative b divided by 2a. What is negative b? Divided by 2a. Negative 4, which is? I want to be clear here, folks. We've said that for this problem, w represents the x-axis because that's your independent variable. Area in terms of w is your y value because that's what your function is equal to. So when you find a coordinate, the x value is w, the y value is area in terms of w. Let's just decide what we truly need here. What are we trying to find in the problem? Is the problem asking for the dimensions or is it asking for the actual area? It says what dimension should he make, so we're trying to find the dimensions. So when I found 60, what does that represent? That's the width. That's the x value of the vertex, the width. So we know that 60 yards is going to be the width. Now, if I plug it back into this function, what would that give me? Would that give me the length or would that give me the area? It would give me the area. Is the problem asking what the maximum area is? No, it's asking the dimensions. So I will go to this equation. It says length is equal to 240 minus 2w. I'll plug 60 into there. And what do you get? 120. So parabolas can be very useful to find maximums, minimums, all sorts of things. Yes. Well, 60 represented the width. I also need to know the length. It says length is equal to 240 minus 2w. So I plug 60 into there. 2 times 60 is 120. 240 minus 120 is 120. Out of these 4 boxes, I feel like this is a good way to organize your work. A lot of people, when they get word problems, their comment is, I don't know where to start. Well, here's where to start. Draw your boxes. Model it first. Then write down your formulas and your relationships. See if you can get your function, and then go ahead and solve it. This is a great way to work with any word problem. Yes? Yep. Think about it. What would be the minimum area? 0. If you simply had a length here of 240, a length here of 240, and then 0, 0, 0, 0, your answer would be 0 for the area. And yet we use... Nope. If the problem makes sense, if it has to minimize something, the parabola would be the other way. You wouldn't have to do that. That's just the way it should work out. If I did this problem and this parabola was not upside down, if I got a plus 2w squared, I know I probably did something wrong. Well, right, you wouldn't be looking for vertex, but there's probably something wrong with the setup of the problem. You probably asked a question that maybe is not asked correctly. So they should work out appropriately like that. All right. So which of the four boxes do you think is most difficult for people to come up and work through? Do you think it's the first, second, third, or fourth? Most of the time, it's the second one. This is kind of the aha moment. You have to understand those relationships and be able to write the expressions and combine them together. Once you actually get the equation and solving it, you guys know how to do that. You practice that the last few days. Generally, you know how to draw the diagram, but this part is a little bit more complicated. So let's practice box number 2, this formula and relationships one. We'll practice it with 4 of these, okay? It says find the function that models the real-life situation. The sum of two numbers is 24. Somebody give me an equation. Sum of two numbers is 24. X plus y is 24. Now it says find a function that models their product. Product is equal to what? What's their product? X times y. So it says it wants a product in terms of x. Product in terms of x is equal to something. I just want x. I don't want y in the problem. So what can I do? This needs to be what I use to come up with this. I got to now change this one somehow. Solve for? Yeah, so y equals 24 minus x. Put that in right there. And we get 24x minus x squared. So the whole key is we have one variable as opposed to two. They're much easier to graph and generate solutions for. A picture is 8 inches longer than it is wide. Picture. Find a function that models the area of the picture in terms of its width. So I need area is equal to length times width. But I want area just in terms of the width. So if that's W, what's the other side? L, which is W plus 8. 8 more than it is wide. Multiply those together, and we get W squared plus 8W. So now I have a function for area that's one variable, not two. Yes? So L minus 8 and L. Like that? Yep, that would be fine. There you're solving for L, though. So you just have to go back and interpret what the answer is. So suppose you get L is 18. Well, then the other one would be 10. Whereas some people would say 18, and they add on 8, and they get 26. Well, that wouldn't be correct. Okay. So just understand from your drawing how you've set it up. Okay, a rectangle has an area of 40. Uh-oh, now they give us 40. Draw a rectangle. We got 40 centimeters squared. Find a function that models its perimeter in terms of the length of one of the sides. Perimeter. What is perimeter? So we can choose to model it in terms of length or in terms of width, because it says the length of one of the sides. And W is one of the lengths, and so I need a secondary equation. Yep. L times W is equal to 40. Now, do you want it in terms of L or do you want it in terms of W? I don't care. Okay, if you want L, then we got to divide both sides by L now. So W equals 40 over L. And I plug that in for this W. So that means perimeter in terms of what's my variable now? L is equal to 2L plus, not 80L, but 80 over L. Feels like a Lord of the Rings. Just want to go home and watch Lord of the Rings. Anybody else a big Lord of the Rings fan? Oh my gosh. Okay, last one. Rectangular box is a square base. Frodo. My favorite character is Gandalf. Love Gandalf. Oh! Samwise Gamgee. So, it says that, or I'm sorry, Mercedes said, can I redraw that? Apparently I'm very gifted in drawing shapes. Boom! Take that, Eli. Boom! I spell your name. All right. Okay. All right, here we go. Square base. Square base, so if that's X, what's the other side? X. It says the height is 3 times more than the depth. So 3x. And I want to write a function that models volume. What's my variable? Yes, volume is length times width times height, but I've already decided what the variable is. What is the variable? Volume in terms of x is equal to, if we multiply the length times the width times the height, what do you get? 3x to the third. We're going to skip 3 because I think we practiced that enough and we want to get to 3 more problems. So we've got 3 more problems to get through. 3. Sure. Farmer puts a fence against a barn. That way he doesn't need fencing against the barn. Cuts down on the amount of fence needed. He's got 320 square feet of fencing. What dimension should he make the fence to maximize the area? Why would a farmer want to maximize the area of a pen? Why is it important to have more room? Can fit more animals. They have more space to do their business. And they have more grass to eat from, right? All sorts of good reasons. So they make the fence. What am I trying to do? Maximize area. So I should write down area equals length times width. What do we call this? Sounds good. W, I like that. Should call this L. Can somebody give me a secondary equation that I can use to relate this stuff together? Close. How many W's do I have? 2 of them. 2W plus L is equal to 320. So let's break it down to one variable. So I'm going to solve and say that L is equal to 320 minus 2W. So we'll take that and plug that back in for L. So now I have area in terms of what variable? W. L goes away. L is gone, right? There are going to be no more L's. There will only be W. So its area in terms of W is 320 minus 2W times W. Or 320W minus 2W squared. What shape does it make? Right side up or upside down? Upside down. So I'll draw my graph. And again, what spot of the parabola am I looking for? The vertex will have location W and A of W. So that's the location. Area. That's like your Y value. So what do I do now? Good. Good. So, good try, not quite. So I came up with 80. What does that mean? Interpret the problem. What did I find? That's my width. I set it up to be my width. What is the question asking? Is it asking for the area or the dimensions? So if I plugged 80 back into here, I would get the area, but I'm not looking for that. Plug area back into here, and it will give me the length. 320 minus 160 is, I thought you said to plug it back into the area function. So the answer is 80 feet by 160 feet. You don't. Matthew is 100% correct. In fact, part of the issue here as well is that you're assuming that this is a flat surface. There could be hills here, and that would change everything. Unfortunately, we're not intelligent enough to deal with multivariable calculus and linear algebra. I've taken the classes already. We could do those problems, but we're not ready for it. So, a box with an open top is to be constructed to form a rectangular piece of cardboard from a rectangular piece of cardboard with dimensions 10 by 18. That's my piece of cardboard. What am I going to do to it? I'm going to destroy it by cutting what shapes? Corners off. What is my objective with this problem? Largest volume, maximize volume. So what should my formula be? Length times height times width. Fine. Look at my length. What is my length right now? When I cut off 2 corners, what will my length be then? Do you remember this problem? We just did this problem a little while ago. Now, look at the width. What is the width right now? And when I cut off the 10 minus 2x. And when I fold up the corner, how high will it be? X. So, because when I When I cut these off, I'm going to fold it right there, and it will fold up this height of x. Okay? So therefore, I have volume in terms of x is equal to, let's FOIL this out. Question, how many x's are there in our volume equation? There are three x's. Therefore, what kind of equation am I going to get? A cubic, yeah, exactly. Something looks like that. So this is not a quadratic, so we're going to have to resort to our calculator to solve this. First, let's multiply it out. Negative 2x times negative 2x times the x will be 4x to the third. Negative 2x times 10, negative 20x, and negative 2x times 18, negative 36. Add them together, I get negative 56, and distribute the x, I'll have negative 56x squared. 18 times 10. 180, distribute the x, I'll have 180x. This is our function in terms of volume. When we graph this, we will come up with this kind of shape. Which spot of the graph are we looking for? The maximum. Maximum happens there, minimum happens down below. We want the maximum. Let's turn on our calculators and do it. Yeah. On domain. I'll clear that up in a second there. Hi there. What can I get for you? Sure thing. Thank you. Yes, Sanders. There you go. All right. All right, let's type it in. 4x to the third. Minus 56, x squared, plus 180x. I will zoom standard. What do you notice about my graph? Okay, Colton asked a really good question there, and I want to dwell on that for just a second. He said that there is a maximum value here, and if we zoom out, we'll be able to see it. In fact, there's a good way to try to decide how to zoom out. Let's think about it. What is the maximum x value you could cut off of this side? 9. You cut 9 off each side, and then you would have 18. What's the maximum value you could cut off here? 5 and 5. So if you notice, look at the graph. The graph crosses through 5 and through 9. Would you guys agree that you could only cut off between 0 and 5, that that's the only thing that's reasonable? So Colt makes a good point. He said, well, isn't the maximum going to be anything over here? All these values are completely unrealistic because their x value is greater than 5. Okay? And there's a reason why they still come up in the graph, but they don't make sense in the problem. Only values between 0 and 5 actually work. Now, give me an example of what you might want to cut off for size. Would you want to cut off 1 inch, 2 inch, 3 inch, 4 inch, 5 inch? What do you want to cut? That would give you 0. Give you 0. What do you want to cut off? 1. Let's say you cut off 1. Okay. Yeah, watch. Let's say we cut off 1. You would get 18 minus 2 is 16. 10 minus 2 is 8. 16 times 8 is 128. Times 1 is 128. So it looks like 128 would be one example of a volume we could come up with. Now, so if we want to raise our window so we can actually see it, we for sure need a value bigger than 128. Don't worry about going too high. Let's just go all the way up to, say, 300. So I'll go negative 300, positive 300, and I'll make my scales every 100 so I don't see too many tick marks. Now if I go to graph, you get a very nice picture of a cubic that I can see. So if you think about the problem, you're able to work it through. Again, we're only concerned about the values of 0 to 5 because that's all that makes sense. How do I find that spot? Second, calculate. Maximum. Enter. I go over to the maximum spot. Once I'm there, I move to the left. Enter. I move to the right. Enter. I enter on guess, and it gives me 2.06 and 168.1. I don't like zoom fit. You can, but I don't know. Try it. I think it does, but so we got 2.06, 168.1. What do those mean? Question. So you can only show part of the graph? Yeah. I don't remember the notation. It involves the comma, and then we have to use some of our our second test, some of our greater and equal than signs, stuff like that. What we actually do is we write a piecewise function. So it's not all that helpful, but we can do it. So here's what we got right there. What do these mean, folks? Tell me. What is 2.06? That's my x value, which means in the terms of the problem, the amount that I cut off. Is that what the problem's asking for? No, it's asking for that is the volume, 168.1. We got time for one more. Yep. Find the dimensions that give the largest area for a rectangle whose base is on the x-axis and whose corners are on the parabola 12 equals, or I'm sorry, y equals 12 minus 3x squared. What does that parabola look like? Yep. Goes up to 12. Looks like that. The rectangle is inside of it. Its base is along the x-axis, and then its corners are going to be on the parabola. What I need to do is to maximize the area, the largest area. I want to find the dimensions that give the largest area. So I have area is equal to length times width. I'm going to try to give a little hint here to you. This corner is x, y. Can somebody tell me what is the length of the base? 2x, very good. This distance right here is over x units. This distance is over x units in the other direction. So therefore, 2x is your length. So area in terms of x will be, we have 2x times width or height. How tall am I? Yes, very good. Only that's not useful at all. Y is a different variable. So instead of y, folks, I need something other than y. Thank you. Area in terms of x is equal to 2x times 12 minus 3x squared. So I have 24x minus 6x to the third. What kind of shape does that make? Except it's upside down, okay? Because it's a negative x to the third. Still, we're trying to maximize. We're looking for that maximum point. Go back to our calculator. Y equals, I'm going to type in 24x minus 6x cubed. And when I do, and I graph it in the same window, looks like my window's a little bit too big. I'm going to shorten it up a little bit. I'm going to go down to negative 100, positive 100. There, I can see it. I'm looking for the maximum. How do I find it? Second, calculate. Maximum. I go to that maximum spot. I move to the left. Enter. I move to the right. Enter. Enter. And I find this coordinate. 1.15 and 18.48. What does that mean? Not the dimensions. 1.15 is simply x. You guys told me that the length was 2x. So if x is 1.15, what is the entire length going to be? 2.3. Because x is how far you are right here, you got to double it because you guys told me that the length is 2 times whatever x is. How do you get the y value? You plug in, I plug in x. What is x? 1.15. So I will plug that in. 24 times 1.15 minus 6 times 1. What? I'm sorry. 12 minus 1.15. Oh, 3 times. 3 times 1.15 squared. And when I do that, I get 8.03. Yep. So you're going to have to, I let you guys know it's normal that people watch the video a second time to get a refresher. I encourage you to do that tonight if you're struggling. This is the same assignment I will give you tomorrow. Okay? So as you look at it tonight, if there's problems that you could do, you should be able to get a few of them done. However, ones that you can't, we are going to learn a couple more tomorrow. You just do part C of 23. Good luck at state, everybody.